All right, welcome back, Algebra 2 students. This is for section 7.1 in the alternate booklet. Much of it is very easy. For instance, they'll give you something like this. It's just a review of exponential functions. I'll just remind you that this is your initial value. It's 5. You're constantly doubling. That means it's an increasing one. Here's the new thing we're going to talk about today. As this function, as you look at it to the left, it never hits the x-axis. It gets very close, but never hits it. Because again, as you have your initial value of 5 here, every step of the way you're doubling to 10 and 20 and so on. Previously, before 5, you'd have 2.5 and 1 1/4, and you constantly have half. So conceptually, you're never going to end up with 0. If they gave you, let's say, a -5. I better throw that there. Now -5 is your initial value, and you're constantly doubling. As you move to the right to -10 and -20, it would look like such. There's going to be some domain and range questions. This function again never touches the x-axis. That's an important thing to note. They gave you this situation. 5 times 2 to the power of x. And then out here, they simply added 3 to it. That would be very similar to this situation. If we gave you, in chapter 4, I believe, a parabola, which is centered here at the origin, and then I said, this time we're going to just add 3 to everything. That moves this every point up 3 units, like that. So back to this one. We know what y equals 5 times 2 to the power of x looks like. It has an initial value of 5, and it never touches the x-axis. Now basically, instead of at 5 and not touching the x-axis, everything is going to move up 3 units. So everything gets moved up 3. So I'm going to put a horizontal guideline here. Your initial value actually gets moved up 3 as well, up to 8. And that's what it looks like. Without that +3, it'd be down here. And now with the +3, it looks like that. Again, Desmos is gonna help a lot when we graph these things. Oops, in that last example, you could also have this situation. This is harder to visualize. Y equals 5 times 2 to the power of x. And if they threw in a +1 up there, that would be like taking your parabola. So now we got to think. And by the x having a +1. This is, we've studied this enough times to know that this is a horizontal shift of 1 unit to the left. So again, same thing here. I could, let me just see if I can lightly draw the original function. This is without that horizontal transformation. And now to take this and move it 1 to the left, it still has this same line here. The whole thing would shift like this. I'll try my hardest to do it. It moves like that. So it looks very similar. The thing I do want you to notice is that what was an initial value of 5, meaning on the y-axis, now appears to be different. It appears to be higher. In reality, all that happened was we just moved that 5 1 unit that way, went 1 unit to the left. The whole function did. So what I'm going to recommend is using either Desmos or some sort of online grapher. You could actually have a double transformation that would look something like this. Y equals 5 times 2. Here they would this would be moving it 2 units to the left. The function moves 2 units to the left. And then out here, this moves it 3 units up. And we ought to be able to have the ability to draw that. So one more time, when you have this function, this is exponential growth. This line that it gets close to actually has a name. The equation is y equals 0. It's a horizontal line. If it moves up, it becomes y equals 2 or 3 or whatnot, and it's called an asymptote. Asymptotes are more things we're going to deal with later on or in college algebra, but right now we'll just note that the important thing is that your function never touches the asymptote. In different scenarios, it could maybe cross it, which is weird. In this instance, the distance between your function and the asymptote diminishes. It gets very close to 0, but it's never going to be 0. Your domain does go far left and far right, so you still have that situation. The range is everything above 0, not including 0. All right, the last thing we have to note, they're going to give you some financial questions. We're going to use this formula, A equals P times the quantity 1 plus R over N to the power of N times T. It looks complicated, but it's not that bad. So A, this is the new amount of money. P is the initial amount of money. They actually call this the principal. R is the interest rate. They give it to you as a percent. You have to rewrite it as a decimal. N is the number of compound periods. I'll try to explain that in a moment. How often you compound. T is the amount of time, and it's in years. So here's what banks do. When you walk into a bank and they say that they're going to give you 6% per year, you actually don't have to wait till the end of the year to get your 6%. If you give them $100, in reality, I know this seems weird, you don't wait a full year and get an extra $6. Or if you give it $200, you don't have to wait a whole year to get 6% of that, which is $12. That's not really how it works. I know it seems weird. In reality, what you guys do is get what's called a monthly interest rate. And each month, you get 1/12 of the interest rate, since there are 12 months here on this planet. And again, if your interest rate was 6%, 1/12 of 6% is a 0.5%. Now, 0.5% is very small. What this means is that if you give it $100, 0.5% is 50 cents. So from January to February, you've gained 50 cents. The good news is that if you do this 12 times, these tiny little interest that you've earned will also start to earn interest, and that's compound growth. After 12 months, you will have you'll have a number greater than the $6 you earned if it was annual, and I'll try to illustrate that concept to you right now. So A, that's the amount, the new amount. We're going to figure that out. Principal, that's what you give the bank. That's $100. We said that in this scenario, your interest rate was 6%. Remember, we have to write that as a decimal. And that's how often you compound it. So you compound it 12 times, meaning both these ends here, this end and that end, they're both 12. And let's just do for a scenario of 1 year. Let's see what this would look like. A, we don't know. P is 100. You always have a 1 here. Your interest rate was 6, so we'll rewrite that as a decimal. This is 12. This is 12 times 1. And now I'm going to do that on my calculator. It's not much more than $106, but it's more. It's $106 and about 17 cents. You guys can confirm that with your calculator. So when I do these problems, you're going to have to look for a keyword that tells you what n is equal to. So now here's going to be a chart for what n is. If they say, so this will be n with words and n as a number. I'll use a hashtag. When they say monthly, the question is, how many months are in a year? When they say daily, the question is, how many days are in a year? And we disregard leap year. When they say quarterly, because this can happen as well, how many quarters or seasons, another way to think about it is seasons, how many seasons are in a year? And then this might be the trickiest one of all, annually. Annually is a year, so how many years are in 1 year? 1. So in that formula that you saw, A equals P times 1 plus R over N to the power of NT. If the word problem had monthly, you'd put a 12 here and here. If they had daily, you'd put 365, etc., etc., etc. So that ought to do it. Have a great day. Take notes. Show me your notes.